Another example of that minimalism is the way that they handle abstraction and name hiding. There are exactly two kinds of name visibility: public and private. Private things can only be seen in the module that declares them. Public things can be seen in any module that imports them. The way that you make things public is by lexical cues. Public things are things that were declared with an identifier starting with a uppercase letter. Fact with a simple F is private, and fact is a capital F.
Now we will be comparing the functionalities of Go language with the other languages such as C, C++, and Java. Strong features as well as limitations in Go language will be comprehensively explicated.
One of the fundamental goals of Go was to be able to compile things really quickly. Lots of things about the language were designed to make it possible to build a really fast compiler and to be able to do full separate compilation without ever needing to reprocess anything. The motivation for this is that Google, they have a very large code base with tons and tons of code reuse. This is a very good thing, but because most of the code is C++, builds can be incredibly slow. The way that C++ header files work with a standard compiler, you can wind up reparsing the same file hundreds or thousands of times.
So even with really fast compiler, you can easily wind up with some extremely slow compile times. Tricks like pre-compiling header can help, but they've got their own problems. Construction speed depends on managing dependencies. Explicit dependencies in source allow fast compilation, fast linking. The Go compiler pulls transitive dependency type info from the object file, but only what it needs. If A.go depends on B.go, depends on C.go. Compile C.go, B.go, then A.go. To compile A.go, compile reads B.o, not C.o. At scale, this can be a huge speedup. Go does not have exceptions. We believe that coupling exceptions to control structure, as in the try, catch, finally idioms, result in convoluted code. It is also tends to encourage programmers to label too many ordinary errors, such as failing to open a file, as exceptional. Go takes different approach. Instead of exceptions, it has a couple of built-in functions to signal and recover from truly exceptional conditions. The recovery mechanism is executed only as part of function state being torn down after an error, which is sufficient to handle catastrophe but requires no extra control structures and, when used well, can result in clean error handling code. Go does not consist generic types. Generics may well be added at some points. We don't feel an urgency for them, although we understand some programmers do. Generics are convenient, but they come at a cost in complexity in the type system and running time. We haven't yet found a design that gives value proportionate to the complexity, although we continue to think about it. Meanwhile, Go builds in maps and slicers. Thus, the ability to use the empty interface to construct containers mean in many cases it is possible to write code that does what generics would enable, if less smoothly. This remains an open issue. No pointer arithmetic. Safety. Without pointer arithmetic, it is possible to create a language that can never derive an illegal address that succeeds incorrectly. Compiler and hardware technology have advanced to a point where a loop using array indices can be as efficient as a loop using pointer arithmetic. Also, the lack of pointer arithmetic can simplify the implementation of garbage collector. Go does not provide implicit numeric conversions. The convenience of automatic conversion between numeric types in C is outweighed by the confusion it causes. When is an expression unsigned? How big is the value? Does it overflow? Is the result portable, independent of the machine on which it executes? It also complicates the compiler. The usual arithmetic conversions are not easy to implement and inconsistent across architectures. For reasons of portability, we decided to make things clear and straightforward at the cost of some explicit conversion in the code. The definitions of constant in Go: arbitrary precision values, free sightness, and size annotations ameliorates matters considerably though. A related detail is that unlike in C, int and int64 are distinct type even if int is 64-bit type. The int type is generic. If you care about how many bits an integer holds, Go encourages to be explicit.
Next steps for Google Go. Regarding what the Go team plans to do in the near term, Pike said, "We have got a few language features that we've been batting around for a while that we'd like to continue to bat around and see if we can make them fit. Things like union types is something that we think we have a good handle on that we haven't had time to implement. The runtime needs a fair bit of development. The garbage collector works just fine, but it's not robust or efficient enough to be a practical solution for a large-scale server. We are very conscious of that. But there's some very clever work at IBM that's been published that we think we can use to guide a much better garbage collector. I think we can solve that problem well. And once we do well, have achieved something really nice. Which is a native compile language garbage collection that works well in a systems environment. Java suffered quite a bit from that, and we are aware of the issues that garbage collection and systems programming have. You tend to worry about pauses where the garbage collector is running. We have to make sure we don't introduce those. Those are the big things that we are thinking about. But we also need a lot of tools. We need a debugger, and then second order things like IDEs and ports to Windows and other operating systems. The Go authors have tried to let clarity of code guide all of their decisions regarding the design of the language. A secondary mission has been to produce a language which compiles quickly, with these two criteria to steer them. Many features from other languages have not made it in. Many programmers will find that their favorite language feature is not present, and indeed some may feel that the language is not usable for lack of certain features common in other languages. Two such missing features are exceptions and generics, both very helpful in other languages. Neither feature is currently part of Go, but since the language is still experimental, these may take fit in there eventually. However, when comparing Go to other languages, we should remember that Go is intended to be a replacement for C in systems programming. And in this light, the various missing features don't look like such a drawback. Finally, since the language has just been released, it does not have much in the way of libraries or tools. There are no IDEs for Go. Standard library has useful code, but it is small compared to what is available in more established languages.